Ever wondered about the stuff all around us? What is it made of and why does it behave the way it does? Welcome to the intriguing world of matter. Matter, in essence, is everything that has mass and takes up space. Yes, that's right. Everything from the air you're breathing, the device you're using, to the stars twinkling in the sky is composed of matter. Now let's talk about the states of matter. You're probably familiar with solids, liquids, and gases. But did you know that there's also something called plasma? Yes, just like in your favorite sci-fi movies. But we'll delve more into that later. Each state of matter has unique characteristics and behaves differently under various conditions. It's almost like they each have their own personality, and they aren't afraid to show it. So, when you're sitting on your chair, typing on your laptop, or even sipping your hot chocolate, you're interacting with matter. Fascinating, isn't it? Ever noticed how water can be ice, liquid, and steam? That's all about the states of matter. Let's embark on a journey to understand the three states of matter: solids, liquids, and gases. Each of these states has unique characteristics and properties that make them, well, solid, liquid, or gas. First off, we have solids. Picture the desk you're sitting at or the device you're holding. Solids have a definite shape and volume. They're like the dependable friend who always shows up on time and never flinches. They don't change their shape or volume unless a force is applied. Now, imagine pouring a glass of water. That's a liquid for you. Unlike their solid pals, liquids have a definite volume, but no definite shape. They're the free spirits of the matter world, flowing and taking the shape of whatever container they're in. Think of them as the friend who always goes with the flow. Finally, we have gases. Picture the air around you. Gases are the wild cards. They have neither a definite shape nor a definite volume. They'll expand to fill any container they're in, or if there's no container, they'll just keep expanding. They're like the adventurous friend who's always up for a spontaneous road trip. To make it even more relatable, let's bring it back to our water example. When water is frozen, it's a solid ice. Leave it out on a sunny day, and it turns into a liquid. Heat it up, and it becomes a gas, steam. Same substance, different states. It's fascinating how these states of matter are all around us, often in ways we don't even realize. From the solid ground beneath our feet, to the liquid coffee that kickstarts our day, to the gaseous air we breathe, matter in its various states is a fundamental part of our lives. So, whether it's the ice in your summer drink, the steam from your hot shower, or the air you're breathing right now, they're all different states of matter. Ever wondered why your ice cream melts or why water turns into steam when heated? Well, we're about to dive into that deliciously cool world of change. These, my friends, are examples of changes of state in matter. Let's take the humble ice cube. It starts as a solid chilling in your freezer. But take it out into the warmth, and what happens? It transforms into a liquid right before your eyes. This is known as melting, a change from solid to liquid. And if you've ever left a glass of water out in the sun, you've seen evaporation in action, where water changes from a liquid to a gas. On the flip side, when you cool down steam, it condenses into water. That's a gas turning into a liquid. And if you've ever made your own popsicles, you've seen freezing, where a liquid becomes a solid. So you see, matter can be quite the shapeshifter, changing from one state to another. Now, you might be thinking, wait a minute, if my ice cube turned into water, isn't it a different substance now? And that's a great question. But here's the fun part. These changes in state are what we call physical changes. The matter might look different, feel different, heck, it might even taste different. Okay, maybe not that last one. But the substance itself, the stuff it's made of, is still the same. Your ice cube turned into water, but it's still H2O, whether it's solid, liquid, or gas. The same goes for your water turning into steam. It's like a magic trick, but the kind where the magician reveals the secret at the end. So next time you're sipping a cold drink or watching the steam rise from your hot chocolate, remember the magical world of matter around you. And remember, physical changes in matter are like a magic trick. The form may change, but the substance remains the same. What about the time when you baked a cake? Did the ingredients remain the same? Nope, they changed into something new. Yes, my friends, we're talking about chemical changes in matter. These are the changes that result in the formation of entirely new substances. Unlike physical changes, which are more like a game of musical chairs where the particles just move around, chemical changes are like a magic show. The old disappears, and something new emerges. Consider the simple act of cooking an egg. We start with a raw egg, clear and runny, but once it hits the hot pan, it turns white and solid. We can't uncook the egg, can we? That's because a chemical change has happened. The heat causes the proteins in the egg to change their structure, creating a new substance. So how can we identify that a chemical change has occurred? There are a few signs to look out for. First, you might notice a change in color. Just like when an apple turns brown after being cut open, or when a statue turns green with age. Second, there might be a change in temperature. Think about when you mix baking soda and vinegar. It gets cold, doesn't it? That's because a chemical reaction is taking place. Third, sometimes a gas is produced. You've seen how soda fizzes when you open it, right? That's because of a chemical reaction releasing carbon dioxide. And finally, sometimes a solid, called a precipitate, forms in a liquid solution. This is why, for example, you might see solids forming when you mix some types of juice. So, you see, chemical changes are all around us, from the food we cook to the air we breathe. They are an essential part of life, and understanding them helps us understand the world better. So, remember, unlike physical changes, chemical changes are like a cooking recipe. New ingredients combine to create a whole new dish. So next time you're cooking or baking, remember you're not just making a meal, you're performing a chemical reaction. Ever wondered why ice melts when you leave it out of the freezer? Or why water boils when heated? Well, let's dive into the magical world of energy and changes of state. We know that matter can shift between three main states: solid, liquid, and gas. But what makes these transformations happen? The answer is energy, specifically thermal energy. This is the type of energy that comes from heat. Picture a block of ice. It's solid, right? The water molecules are all huddled together, not moving much. But when you take that ice out of the freezer, something interesting happens. The ice starts to absorb thermal energy from the room. As it soaks up this energy, the water molecules start to shake, shimmy, and slide around, breaking their bonds. This is when we see the ice transform into a liquid state. It's melting. Now, what if we apply more heat to this liquid water? As you might have guessed, it starts absorbing more thermal energy. Those water molecules start moving around even faster, breaking more bonds until they have enough energy to escape as a gas. And voila, you've got steam, the gaseous state of water. But the fun doesn't stop there. Changes of state can go the other way too. When gas cools down, it loses thermal energy and the molecules slow down. They start to stick together again, forming a liquid. And if that liquid cools down even more, it loses more thermal energy, and the molecules slow down so much that they lock into place, forming a solid. In essence, thermal energy is the driving force behind these changes. It's like the fuel that powers the engine of state changes. When matter absorbs thermal energy, it can transition from a solid to a liquid to a gas. Conversely, when matter releases thermal energy, it can transition from a gas to a liquid to a solid. So, energy is the secret ingredient that drives the changes in the state of matter. Cool, right? Why is metal used in bridges? Why are balloons filled with helium and not air? Well, folks, it all comes down to the unique physical properties of different types of matter. Let's take a closer look. Metal, for example, is used in bridges because of its strength. Its solid state allows it to bear a lot of weight without breaking or deforming, making it ideal for those massive structures that need to stand up to cars, trucks, and sometimes even trains. It's also resistant to weather, which is a pretty big deal when you're building something that needs to last for decades. On the other hand, helium is used in balloons because it's lighter than air. This gas has a lower density, which means it rises above the heavier air. Fill a balloon with helium, and it floats right up to the ceiling or even the sky if you let it go. That's not a magic trick, it's just science. And what about liquids? Well, think about oil. It's used in car engines because it has a high boiling point and can withstand high temperatures without evaporating. This means it can lubricate the engine parts, reducing friction and helping to keep the engine from overheating. And we can't forget about water, the most versatile liquid of all. Its unique properties make it essential for life. For instance, it has a high heat capacity, which means it can absorb a lot of heat before it starts to get hot. This property helps regulate temperatures in our bodies and on our planet. But even beyond these examples, countless materials are chosen for specific tasks based on their physical properties. From the rubber in your car tires to the glass in your windows, every material has a job to do. So the properties of matter aren't just fun facts, they're the reason why we use certain materials for specific tasks. So, we've been on quite a journey, haven't we? Let's review what we've learned. Our journey started with understanding that matter is, well, everything. It's all around us, making up every object and organism. It's everything that has mass and takes up space. It's what gives substance to our world. Then, we dove into the states of matter: solids, liquids, and gases. Solids are like the steadfast, reliable friends who keep their shape no matter what. Liquids are the adaptable ones, changing shape to fit their container, but keeping their volume constant. And gases? They're the free spirits, expanding to fill any space given. We then explored the changes of state in matter. Remember how we said matter could be a bit of a shapeshifter? That's right, by adding or removing heat, matter can transform from one state to another. When your ice cream melts, it's changing from a solid to a liquid. When water boils, it's changing from a liquid to a gas. But that's not all. We also delved into the world of chemical changes. These changes are like a magic trick, transforming one substance into another. When you see a cake baking in the oven or a battery powering a device, that's a chemical change in action. And speaking of action, we also touched on how changes of state can occur when matter absorbs or releases thermal energy. Think about that ice cube melting in your drink on a hot day, or the condensation on your window in the winter. That's thermal energy at work. Last but not least, we discussed why specific physical properties of various solids, liquids, and gases make them useful for particular applications. From building materials to cleaning products, the properties of matter shape our world in countless ways. So there you have it, a whirlwind tour of the properties of and changes in matter. It's a vast and fascinating field, and we've only just scratched the surface. Next time you see ice melting or bread toasting, remember you're witnessing the fascinating world of matter in action.